I'm from Davidson High School, and we were wondering with the recent advances in technology, what changes would y'all make to the new Mars rovers that are going to go up there?
The new Mars rover. So there's a lot of interesting technology on them. One neat thing is, I'm sure you guys have all seen the video of the rovers, the MER rovers, when they landed on Mars, they inflated these airbags and bounced around. And that's kind of how they landed. This time, the MSL, the new Mars rover, we're actually going to send the rover to Mars. It's going to parachute to the surface, and then we're actually going to have some boosters, some rockets on the bottom of this little lander that's on the rover to actually make it hover. So we're going to hover the robot up in the air, and then take a little line and actually lower it with a rope. So kind of lower it with a cable down to the surface. So that's going to be interesting. So we're not going to do any more bouncing. We're actually going to hover and then lower the robot with the rope. So that's some new technology that we're going to be working on. Also, it's going to be a lot bigger. We're going to have a stronger robotic arm. We're going to have a lot more instruments. On the MER rovers, most of the instruments were trying to look for water. On these rovers, on the next rover that's going up, it's going to have a lot of instruments that are looking for light. So those are a whole different thing. So looking for carbon, looking for organic molecules that you guys have probably learned about. So all those different things. And then in the far future, we're hoping to have robots that can actually maybe build things on Mars, like actually build habitats and build structures for people in the future. So one project that we've been looking at JPL is having two robots working together, carrying beams and structures and stacking them and kind of building structures. So that way, instead of having to have astronauts sit around and have to build their own houses to live in, you can send robots with materials there and have them construct something for you. So when astronauts land, they'll have something to live in. So those are some technologies in the further future that we hope to implement on Mars. Yeah.
I'm John Powell from Berkeley High School. I was wondering, well, since you just talked about construction, so I was wondering, because of differences in like gravity and pressure and temperature and all that stuff, are you guys working on any new type of materials to use on Mars instead of just regular like steel and whatnot? And if you are,
yeah, definitely. We're always looking at new materials. A lot of synthetic materials, a lot of materials that work good in cold as well as hot temperatures. So they're always developing new composite materials like carbon composites and honeycomb materials. And the reason why that's important is because when things get really cold, they shrink, and when things get really hot, they expand. And that can cause a problem with the robot, for example. If you have two cameras, for example, that are sitting on a piece of metal, when it gets really cold, the cameras are going to get closer together. When it gets really hot, the cameras are going to get farther apart. And then that can kind of mess up the way the robot sees. Kind of like, when you cross your eyes, you can't see right. So that's stuff like that. Funny stuff happens. But with the composite material, things don't shrink or expand as much. So that's some new stuff that we're always looking at. Also, we're looking at things that are lighter and stronger. So again, like a lot of composite materials. Things like parachutes and airbags for Mars rovers and things. Originally stuff was made out of, airbags and stuff like that might be made out of nylon or cotton or something like that. But there's some new materials that they've been using called like Vectran, which actually is kind of cool because it gets stronger when it gets colder. So a lot of those kind of materials they use for different things. And there's always new types of ways, actually not just metals, but new types of ways to use the metals. So you can shape the metals in different ways that they act more springy, so you're able to absorb shock when the robot's landing. So you think a metal is just real hard, but if you curve it in the right way, it's kind of like springs, I guess. If you curve them around, they can get soft and absorb shock. So materials as well as the way we use materials and we build things with them.
Yeah.
My name is Connor Denton and I go to Corpus Christi School, and I was wondering how long would it take for a spacecraft to actually make it to Mars, and how fast would it need to travel to get there?
Good question. So Mars is really, really like millions of miles away. So it's actually It's not, going to Mars is not like going to Alabama or going to Mississippi. Further, it takes, the rovers took 6 months to get to Mars. So that's about how long it takes right now to get to Mars. I'm flying continuously for 6 months. And get this, there's no speed limit in the space. So, you can fly as fast as you want. And the spacecraft going to Mars actually reach speeds of maybe like 12,000 miles per hour. So that's pretty fast. That'll rip the top off of your convertible. But actually there's no space, so it wouldn't do anything in space. But yeah, it's really fast. So it takes a long time to get to Mars, and you got to go really fast to get there. Faster you can go, the quicker you can get there. And actually, the people have actually done some studies on how going really fast in space will affect people too. I remember when I was working up at NASA Ames Research Center, which is near another NASA center near San Francisco, we were actually having people live in centrifuges. So I'm sure you've all seen centrifuges that spin around and throw stuff to the side. If you spin around something really, really fast, it kind of creates gravity against the wall. So like you see those future space stations, they're all round and they spin around and people walking on the outside. And that's because you can kind of simulate gravity by having something spin around. But they were actually having someone live in one of these centrifuges, like a huge 30-foot long centrifuge. So they were simulating 2 times the Earth's gravity. So imagine being twice as heavy and trying to live like that for 6 months. So they were actually, the idea would be to accelerate a spacecraft to Mars at a real fast rate. The person in the spacecraft would be feeling 2 times the force of gravity. Kind of like when your car is accelerating, you get pushed back into your seat, or like a roller coaster. So you feel all those G-forces, what they call them. So, that's really short term. But imagine trying to live in that for 6 months, flying at real fast speeds and feeling 2 times the force of gravity. And then to slow down, of course, because you can't crash into Mars, you have to slow down. You flip the spacecraft around and then slow it down. So then you'd be feeling 2 times the Earth's gravity backwards as you slow down. So it's a long time to get there, and there's been a lot of studies that we've been doing to figure out how fast we need to go and how fast we can to get to Mars. Yep.
The tipstick. What is this?
My name is Timothy Battle. I'm from Praise Christian School. I was wondering, are the Mars rovers controlled by recorded voice commands, command prompts, English text, or anything similar? And if not, how are they controlled?
Oh, good question. So the rovers on Mars, they're actually controlled by, there's a lot of people that sit up on computers and they just type in text, they type in numbers and type in commands. And also, click buttons to send commands to the rover. And what we actually do is, since it takes a couple minutes for stuff to get to Mars and stuff to get back, you can't control it like a remote control car in front of you, just because it's too hard. And so what we do is we actually enter all these commands and create a long list of commands, pretty much a whole set of instructions. And then we upload those to the rover overnight, all the information gets sent to the rover, and then the rover reads those commands that we wrote and follows them in a sequence. So we only do that once a day. So we write a whole sequence of commands for the rover, like drive 10 meters forward, turn right 20 degrees, take a picture, put the arm down, grab a sample, or analyze a sample and stuff like that. So all those things we put together and then send them to the robots and do that. But in the future, there's probably going to be different ways that we can control the rovers as well too. And I remember even astronauts, I know they're coming out with new stuff for astronauts, for example, that are voice controlled. So you can have instruments that you can just control with your voice that be able to do stuff. So we're looking at that stuff as well. Yeah.
My name is Nick Pruitt of Clark School of Math and Science, and I was wondering, what would you consider about the possibilities of future changes in the atmospheric conditions of Mars, either man-made or natural, to contribute to sustaining life on Mars?